Exponents and logarithms. In this video, we'll be talking about the rules for exponents and logarithms, and I will also be mentioning for the base change rule for logarithms. Hope this helps. So the first thing we'll do is understand the rules for exponents, and these are all written in the general formula, so I hope this helps. First situation is a to the power of p multiplied by a to the power of q. In this situation, the rule says that a to the power of p plus q will happen. So the second rule is when there's a to the power of p, it is divided by a to the power of q, we will get a to the power of p minus q. Notice how these two rules are completely different just because of the multiplication sign and the division sign. So the third rule is when a to the power of p is in brackets to the power of q, we will get a to the power of p times q. Fourth rule says 1 divided by a to the power of p. Well, let me explain. We are not really solving anything here, but we are changing how it looks to get another perspective to the problem. So we have 1 divided by a to the power of p. This will become 1 times a to the power of minus p. So fifth situation is when there is a problem that looks like this, we will get a to the power of p divided by q. The p, which is inside the square root, will be the numerator, and the q, which is outside, will become the denominator. Now the sixth rule is a to the power of 0 is equal to 1. This is a given obvious thing, so a to the power of 0 is 1. It is just 1. So let me give you some really quick examples for this. Say we have, the first rule, which is here. I'm going to be following these numbers. So we have 2 to the power of 2 multiplied by 2 to the power of 6. This will become 2 to the power of 2 plus 6. This will then become 2 to the power of 8. Second rule, which is here, will become 2 to the power of, say, 2 divided by 2 to the power of 6. Well, we'll get 2 to the power of 2 minus 6. This will become 2 to the power of minus 4. Third rule will be, say there's 2 to the power of 2 in brackets to the power of 6. This will become 2 to the power of 2 times 6. Now we will get 2 to the power of 12. Fourth rule is, say we have 1 divided by 2 to the power of 2. This will become 1 times 2 to the power of minus 2, which will then eventually be 2 to the power of minus 2. You can simplify that. So fifth rule is, say we have 2 here. In square root we have 2 to the power of 3. Or say, okay, I'll give you an easier one, say it's 2 to the power of 12. So now you have 2 to the power of 12 divided by 2, which is, this is 2, sorry, is the 12, which is inside the square root, will be the numerator, and the 2 will be the denominator. This will just be 2 to the power of 6. So now we have the sixth rule, which is a given. Say we have 236 to the power of 0. This will just be 1. Say we have this number to the power of 0, it will just be 1. So these are quick rules for exponents, and these are important when you're solving a problem, and now I'll show you a problem. So say we have these two examples. Let's start off with the first problem. X to the power of 1 by 5 times x to the power of 2 by 5. Now, this is multiplied, so we'll be using our first rule. So you can go back and look what the first rule was, but I'll just explain it here again. This will be x to the power of 1 by 5 plus 2 by 5. Now we go on to our second part, which will be our fifth rule. This will just be x to the power of 3 by 5. Notice that the 3 inside will be the numerator and the 5 will be the denominator. I know I've said that a lot of times, but again, so now you just simplify. It will just be x to the power of 3 by 5 divided by x to the power of 3 by 5, which will simply be 1. See how something scary can just become something so easy if you know your rules. So you have 2, the example 2, and you can write this as 1 divided by a to the power of 2 by 3. This is the fourth rule, and now this is just the reverse of the fourth rule, sorry. And now you can simplify that by writing it like this. So you have 8, this is the fifth rule. The numerator goes inside and the denominator goes outside. This can be simplified to 1 by 2 to the power of 2. This will just be 1 to the power of 4. This was very easy. The rules apply to this, so you can see that every step uses the 6 rules I gave here. Now we will be carrying on to rules for logarithms. Rules for logarithms are the same as exponentials, just different kind of writing. So say log of base a x times y. This can also be written as log of base a x plus log of base a y. The second is log of base a in brackets x divided by y. This will just be log of base a x minus log of base a y. So we're just separating the log ax, log a y. We're just doing that same thing here. And notice how this is similar to the exponential rules, that the multiplication becomes addition and the division becomes subtraction. So say we have this now, the third situation, log of base a x to the power of m. Well, this is just repositioning our m, and you put your m here in front, so it'll be m log base a x. Same as the one example I gave in exponentials. By changing how the problem looks, it will make your problem easier to solve. So fourth situation is log of base a in brackets 1 divided by x. This can be written as minus log ax. So these are the main 4 rules. Actually, these are the main 3 rules, and this is just a good to know fact. Okay, so now let's go on to the examples, and I'll be solving that here. So the first one, I'll write that big. So you have log of x base x plus log of x 3 minus log x 6. So what you'll do here is, well, you know that this is addition, and as we saw in the previous page, addition when reversed of logs can be multiplication. So this is log of x in brackets 8 times 3. Now you still have minus log x base x 6. Well, we know that the subtraction means division actually when it is reversed here. So it will just be log of x 24 divided by log x 6. Further on, you can just make this log x 24 by 6 and then simplify that to log x 4. So this will be your answer. So now we go to our next problem, and this was our next problem, which is 2. And this was 3 log p to the base p to the power of 2 minus log base p to the power of 12 plus 2 log base p to the power of 4. This looks harder, but believe me, if you use your rules, it is not. So what we can do here is say we see that we have a subtraction here and we have an addition here. So what you can turn this into, I wrote this slightly incorrectly. This is just 2 because this is the base. So what you can, first, let's start off with this. 3 log p base 2. So as we saw in the rule 3, the m, which is x to the power m, the power goes in front. If we reverse that, we can put the power up again. So it'll be log p 2 to the power of 3. So, okay, let's write that down. So it'll be log base p 2 to the power of 3 minus, now we have this, so let's say that's just log base p 12. We can't really do much to that. So now we have plus, we do the same thing here, we just put log base p 4 to the power of 2. Now multiplication comes before division, and addition also comes before subtraction. So what you have here is log base p, this is 8, and now you have minus log p 12 plus log to base 16. What you can write this as is log p 8 times 16 divided by, this is bracket, should be a big bracket like this, divided by 12, and this will just give you log p 32 by 3. Alright, so you can see how the rules apply to that problem as well. Going to our third problem, this one. The third problem is 2 log 10 of 5 plus 2 log base 10 of 2. What you do here is just log 10 5 to the power of 2 plus log 10 2 to the power of 2. You just simplify that as log 10 25 plus log 10 4. Now you can just multiply that, and that will just become log 10 100, and basically you can just simplify that to 2, because log 10 to the base of 10 100 is just 2. So now we will look at the change of base, and this is not a rule, but it will come later, and it is handy when you're solving problems. So you have log a of x. So say you have log 2 base 2 of x, but your problem requires you to solve only in log 6's of x. So the general formula for this is that, okay, so you have, say, log base a of x. What you do then is, okay, you have you say you want your base to be b, so you take, okay, that's going to be log b, x will go on top, so whatever the number x is will be a numerator, and the base will go below with the desired base b. So say you have a really easy example. Say you have log 2 of x, but you want log 6, everything in 6's, so base 6's. So you just do log, okay, my desired is 6, x will come here, divided by log desired base 6, and the base, the original base, will be here. So you can just solve it like that. And I can give an example, which, say the first example I'll give you for this is log 9 of x plus log x base x to 9 is equal to 3. How you would solve that is you would change the, it's 2 log, sorry. And what you would do is log 9 of x plus log x base 9 to the power of 2 using our base laws. And when you are doing a base change, because you want your logs to be in base 9, not x, what you will do with this is, okay, so you have this rule, you have log x 9, 2, and you want your desired base to be log 9. So what you'll do is, okay, I have log 9, my desired base, and here they have 9 divided by log the desired base and your original base, which is x. So log 9 of 9 is just 1. Log 6 of x. Now don't forget your 2 in front, so it'll just be 2. And what you'll get here is log 9 base 9x plus 2 log 6x is equal to 3, and then you can later just solve that out. Okay, I hope this helped.